Okay, so I'm going to work an old one from your old homework, and I'm going to use one where I have these fractions that I'm trying to add together. So I notice here that this is definitely my more complicated side, so I'm going to pretty much be using the left-hand side. And I have two fractions with different denominators. So this is an example where I'm going to need a common denominator. So I'm going to need to show my process of actually getting a common denominator, because right now I cannot do 1 minus 1 over on the top because my denominators are different. So when I have a common denominator, then I'm actually going to combine the fractions so that I can simplify. So the ultimate goal is going to try to combine these fractions, because here I don't have any fractions. Simply simplify. I'm going to try to combine these because then I can have one nice term that doesn't have like any subtraction of fractions. So if I'm looking here, I have a 1 minus sin x and a 1 plus sin x. To refresh your memory, if I had like 2 over 3 and I'm trying to add like 5/4, I need to come up with a denominator that I can use for both of these. The easiest thing is I think of 12, right? 3 and 4, the closest thing to 12. Well, to get that, I need to multiply this fraction by 3, because I get 4 times 3. But I need to multiply this fraction by 4. So by multiplying the tops and the bottoms multiply. So I would get 8/12 plus 5 times 3, which is 15/12. And then I could actually add them together because then I have the same denominator. So looking here, I'm going to multiply this left fraction by 1 plus sin x over 1 plus sin x. I want to emphasize that we don't want to do 1 over 1 plus sin x because we still want to multiply by 1, meaning the same thing on top and bottom. If I just did 1 over 1 plus sin x, I'm not actually multiplying by 1, and that would actually change what my equation is saying, because anything multiplied 1 is the same thing, so we want to keep it that way. So here's my original, 1 minus sin x. Then the other side is the 1 over 1 plus sin x. And that is the fraction I'm going to need to multiply by 1 minus sin x over 1 minus sin x. So again, we always want to be multiplying by 1 to keep these the same. And I forgot to write left-hand side to emphasize that's what I'm doing. So now I'm going to just multiply each of these on their own. So you don't have to show the circles, but I'm just showing you to know what you're doing. So I'm doing 1 plus sin x times 1. So my new numerator is actually going to be 1 plus sin x. And my denominator is going to be 1 plus sin x times 1 minus sin x. Then on the other side, I have a minus. And then I'm doing 1 times 1 minus sin x. So I'll still have 1 minus sin x on top over 1 plus sin x times 1 minus sin x. So now this is where I'm at. Because I have the two denominators that are the same, now I can actually scrunch the numerators together. One thing I need to be extra careful about is this minus sign. So when I write this, I need to make sure I'm subtracting this entire fraction. So watch carefully for how I'm going to rewrite the numerator. I still have 1 plus sin x on top, but I have a minus 1 minus sin x because I'm subtracting the whole numerator. And you'll see that this is going to affect my signs. I saw a lot of people just write negative 1 minus sin x, but you're not distributing that negative if you don't actually, if you write it that way. Sorry, I'm trying to do this with one hand. Okay. So on the bottom, I still have 1 plus sin x times 1 minus sin x. So at this point, I'm going to distribute that negative to be extra careful. So now I'm going to have 1 plus sin x. And again, I'm drawing out the steps, but you just want to be extra careful for each of these algebra steps. 1 plus sin x over 1 minus sin x. Notice how neatly, though I'm trying to write my work, they're really going to be looking for this when they're grading your common assessments. Okay, so these ones are now going to cancel. Ta-da! But now I'm going to have a sin x plus sin x, which is actually going to be 2 sin x's. So at this point, now I'm going to have 2 sin x's. Not sine squared because I'm not multiplying. I have a sine x plus a sine x, meaning I have two of them. If I was doing sine x times sine x, I'm multiplying something by itself 2 times, which is when you write the squared. Now, I notice already I'm not going to be able to cancel anything out on the bottom, so I'm going to go ahead and multiply these together as well. To remind you of another pattern, if I have an a plus b times an a minus b, there's a shortcut. What happens to your box is that middle term goes away. So you'll have a squared minus b squared because a plus times a negative gives you a minus. This is a really quick pattern to multiply if you see something in this pattern. Again, you can always prove this by using the box, but I like to memorize these patterns because then I don't even have to do the box when I write this on the bottom. So I'm going to have a squared minus b squared. So my a is 1 and 1 squared is 1 minus sine squared. So now I'm here. Still cannot cancel anything though, so I'm still in a little bit of a bind. I still have this like minus sign and I want to be able to at least like write some kind of tangent and secant. Well, I see that I have 1 minus sine squared x, so I see like that I have that 1 and a sine squared. Let me go back and remember my Pythagorean identities. Here's sine theta plus cosine theta equals 1, but I have 1 minus sine squared theta. So if I want to get 1 minus sine squared theta, I essentially need to subtract sine from both sides, and that actually leaves me with cosine on one side. So this is just multiple times I've done it in different ways, but you see that if I subtract sine from both sides, then I'm left with cosine. So I'm going to rewrite my 1 minus sine squared theta as actually cosine squared theta. Okay, so now I'm here, and you're probably like, well, Miss Hindi, how am I going to get tangent and secant? Well, up here I remind myself that tangent is the same thing as sine x over cosine x, and secant is the same thing as 1 over cosine x. So both of these have a cosine x in them. Would you agree? And if I were to essentially multiply these, and you don't have to do this, I'm just showing an idea, then I would actually get sine x over cosine squared x, right? Because cosine times cosine is cosine squared. So if I have a cosine squared, just like on a previous example, how I can split up if you're multiplying, I'm actually going to rewrite this as 2 sine x over one of the cosines multiplied by, I still want to keep the same numerator, so 2 sine x times 1 over, but I have 1 cosine x times another cosine x will actually give me cosine squared. And the reason I do that is because now I have a sine x cosine x and a 1 over cosine x. So at this point now I know, okay, well sine divided by cosine is tangent, so I still have that too, just hangs out. Tangent x, and 1 over cosine x is secant x. So this is a really critical move if you felt, this is a really critical move if you felt like you were stuck. Know that you can still separate fractions just like you multiply, but remember that you kind of have to think the reverse. So make sure that you don't put cosine squared times cosine squared because that would give you cosine to the 4th. Just make sure you're kind of doing the opposite. And you can always check and go back and make sure you can get the same thing when you were to go backwards. That's equal to my right-hand side, so I'm good to go.